Hi everyone. So today we're going to be working on graphing our radical expressions or functions. So we're going to be doing the square root and we're going to do the cube root. So the easiest way I can tell you to do this is we're going to make a chart with common perfect roots. We're going to find the y values, we're going to plot the points, and then we're going to apply a transformation. So it's the easiest way I can tell you to do this. Okay, so let's start with the square root. So we're going to graph radical functions by the time we're done. So we're going to graph the square root. So let's make a chart. It's the easiest way I can tell you to do it. Okay, so I'm going to put in perfect squares. Now, keep in mind we can't take the square root of a negative number, so I have to start at 0. We don't have a choice. And then next perfect square after 0 is 1, 4, and 9. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, the square root of 9 is 3. Okay, so that is what we're going to graph. Oh, what color do we want? Let's go with the red, or the funky pink, whatever you want to call it. So we got 0, 0, 1, 1, 1, 2, 3, 4, 1, 2, 5, 6, 7, 8, 9, 1, 2, 3. Okay, so we have this like half weird arc looking thing. So the thing about square roots is that in the graph we have to start at 0. Okay, our, shall we say, domain is all real numbers. Our domain is greater than 0. And the same with the range. Okay, greater than or equal to. Now that's for the basic graph. Okay, this has no changes. This is like the square root of x. That's what the graph looks like. Okay, now we're going to do the same thing with the cube root. We're going to make a little chart. Okay. All right, so because I'm going to do cube root, we can take the cube root of negative numbers. So I'm going to find some nice perfect cubes like -8, -1, 0, 1, and 8. So the cube root of -8 is -2. Cube root of -1 is 1, 0, 1, and 2. And that's what I'm going to plot. This time, let's go with mint. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, down 2, -1, 1, 0, 0, 1, 1, and I think 8's here. 1, 2, 3, 4, 5, 6, 7, 8. Nope, I was wrong. Okay, so this one, and it looks a little curve, like that. Okay. All right, so again, these are our two graphs, and every graph that we're going to do is going to have like this shape. Okay. All right, so here the domain and range are both all real numbers. Maybe we can make that funky R. Okay. All right, so let's graph this first one. 2 square roots of x minus 3 plus 1. So we have a change here, here, and here. So we're going to start with the 2. And the easiest way I can tell us to do it is make a chart. Square root 0, 1, 4, 9, 0, 1, 2, 3. Okay, there's your base, there's your basic graph, or what would be referred to as the parent graph. And now we're going to take the 2 and apply it to the y. So I'm going to give that a different color. So this is 2y. So 2 times the y values. So 0, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. Now that's what we're going to graph. Okay, so I'm going to graph the original. I guess we'll use this blue for the original. Okay, 0, 0, 1, 1, 4, 2, 9, 3. Okay, so this is the original. Okay, just so you can see the difference. Okay, so this is the transformed. Okay, you can see that it's been stretched. Okay, away from the x-axis, closer to y, so there's your vertical stretch concept. Okay, so now our last graph, we'll do it in a minute. Okay, do we see the 3 and the 1? So remember, this is going to move the graph 3 units right and 1 unit up. Okay, so remember, inside is always opposite. Okay, so I'm going to move this graph 3 units right and 1 unit up. Okay, so 3 units right, 2, 3, right, 1, 2, 3, 1 unit up. Okay, so I'm taking my best shot here. Okay, now we don't have to do it physically. We can always copy and paste, and I'll do the next one like that. All right, so why don't you pause the video and try the next one just like that. Make a chart. If there's a number in front of the square root, you're going to multiply the y's by him. And then if there's a number added or subtracted inside, we're going to move it left to right and then up and down. All right, so let's see what we came up with. Oh, I guess I used orange. Okay, so the purple is the one with the 1/2, and then the orange is 2 units left and 4 units down. Okay. All right, so let's try the cube root. Okay. All right, so we'll do that in the blue. Okay, so I'm going to make my chart. So -8, -1, 0, 1, and 8. So -2, -1, 0, 1, and 2. Okay, so that's the original. Okay. All right, so now we're going to multiply all our y's by 3. I'm going to make this here. So just add to the chart 3y. So that's -6, -3, 0, 3, and 6. All right, so over, okay, so we're 5, 6, 1, -3. We're still in 0, 0. 1, 3, 8, 6, 2, 3, 4, 5, 6. Okay. Again, that's not the best, but now this graph, the last graph, which I'm going to do in mint, but I'm just going to pick it up and move it, is 1 unit right, 2 units down. Okay. All right. Okay, so let's see the easiest way. Okay, so I'm going to take this guy, and I'm going to go from the origin, and I'm going to move him 1 unit right and 2 units down. So move the origin to 1 unit right, 1 unit right, and 2 units down. Okay, notice I didn't grab all of it when I circled. So there we go. And that is our final answer. Okay? All right, so pause the video and try the next one. Okay, there it is. The orange one is the transformed one. They call it transformed. Okay. All right, so let's do why do we care? All right. A sprinkler can water between 1 and 130 square yards of a lawn. So if you've run a lawn care business, that's important. The length L in the inches of rotating pipe needed to water A square yards is given by the function L length. It's 117.75 times the square root of A, which is the yards. Graph the equation on your calculator. Okay, so let's see if I can pull this up and not burn my recording. Nope, okay, we're good. So I'm going to turn off the recording. Okay, so let's go to our y equals. And we're going to plot 117.75 square root of x. Okay, we don't have a's. So graph, we're not going to... Okay, so there it is. Okay, so we're going to sketch that. All right, let's move this down. Okay, and we definitely are like going like that. All right, so how much area can be watered if the length of the pipe is 500, 800, and 1300? So the length of the pipe is L. So it's kind of like 500 is equal to 117.75 square root of A. Now there's two ways we can do this. We can solve or we can just look at the graph. I'm going with the graph. All right, so if we just touch our graph, we want to know when is the y value 500. I think I'm going to have to move my graph so I can get some more information. What do we got? 800 and 1300. Okay, so I'm looking at my y's. All right, so I want to know when is my y value 500. So it looks about 18 square yards. So that's the x value. So now we're going to do 817.75 square root of A. Okay, so now I'm going to move my cursor to 800 and look at the x value. All right, so it looks about 46 yards. Here we re-walk you on my video. All right, and then 1300 is equal to 117.75 square root of A. Okay, so I want to move my cursor to 1300 on the y. I need to move my graph. Yep. It's 1300. All right, so it looks like 122 yards. Okay, that's why do we care? All right, let me know if you have any questions, guys. I'll talk to you again real soon. Stay safe out there.